So today we are going to talk about Software Engineering 1, Lecture 25. So first let's do some recap on Lecture 24, where the verification and validation are not the same thing, where the verification shows the conformance with specification, and the validation shows the program meets the customer's needs. And test plan should be drawn up to the guide of the test process, which means that maybe in the system design we have the customer system plan, and maybe you have in the integration part you have the integration test plan, in the subsystem part you have the subsystem test plan. Therefore, additionally, the different types of system program introspection, which means that trying to do some paperwork in validating whether the software is valid or not. And the different types of program, the system development process require different levels of verification and validation. Which means that if we are designing a rocket, it is going to be it takes more testing. And if we are only designing maybe a mathematical modeling algorithm, it's kind of easy. They may not, as long as they can produce some beautiful graph, it's fine. And so today we are going to talk more about testing, where the defect testing is involved testing the program to establish the persistence of system defects. It just means that if you cannot find the defects, then that means that there isn't the defects. The object of today's the objects of the testing is to understand the testing techniques and that are geared to discover program faults, and to introduce the guideline for the interface testing, and to understand the specific approach to the object-oriented testing, to understand the principles of the case, which means the computer-aided software engineering tools to support testing. So the topic to be covered is the defect testing, integration testing, and object-oriented testing and testing workbenches. The testing process is component testing, which is testing of individual program components, and usually the responsibility of the component developer is sometimes the critical system, because we are testing whether the system is work or not, and it is the software engineer who do that. Therefore, it is them to test them, and tests are derived from the developer's experiences. Along with that, we have the integration testing, the testing of the group of components integrated to create a system or subsystem. The responsibility are independent testing team, and the tests are based on the system specification. So who are the independent testing team? It's just like software testing company, just like maybe, or it's a software testing team within a company. Therefore, the component testing is here, and the integration testing team is here. So the defect testing, the goal of defect testing is to discover the defect of the program, and the successful defect test is the test which causes the program to behave in is the test which causes the program to behave in a enormous way. This is very interesting thing that. If the test case is successfully tested to be wrong, it is a good test case. That's a very good thing, right? And the test shows the persistence, not the absence of the defects. It's just to figure out more, right? The testing prioritizes the only exclusive testing can show the program is free from defect. However, exclusive testing is impossible. The test shows the expertise of the system capacity rather than its components. Testing old components is more important than testing new capacities, and testing typical solutions is more important than boundary solutions. This is where it was noticing that the capacity is just like what can so the majority of things should be the typical situation and the old capacities rather the the new and boundary test cases. And the relation between test data and test cases that the test cases is a larger concept and test data is a smaller concept. The test data inputs which have been derived to test the system. The test cases inputs to test the system and predict the output from this. The test input is to test the system and predict the output. It's test the input and predict the output from this if the system operates according to the specification. And the test plan templates, there are 1, 2, 3, 4, 5, 6, 7. There are 7 cases for the test plan, where it's the name of the cases, the description, the input data, the action, the expected output, and the actual output, and successful fail. So as long as it's predicted output and the actual output are the same, it is success, and everything else, it is fault. The name of the case, maybe in this case, is login OK pass. The test the login with a good username, and username equals test1, pass1, click OK, then login OK, success. But the last one is it does not input the password, but it's still login OK. But the expected output is failed to locate, therefore it is failed to pass the test. Maybe it should the problem with handling the maybe empty string, something like that. And the defects testing phases are involved the maybe design the test cases and test the cases, prepare the test data, generate test data, run the program with the test data, and get the test results, trying to generate the test report. Therefore, the test report will include the test data, test result, test cases, and generate the test reports, right? And the design test cases is based on the specification of the program. There are some 2 kinds of testing, which is called blackboard testing and whiteboard testing. The blackboard testing is approach to test whether the program encountered at the blackboard. The program cases are based on system specification. The test planning can begin early in the software development process. The blackboard testing is that we input set of data, input causing the anomalous behavior. The system, the output has data. The output which reveals the persistence of the defects. We put the input and get the maybe not good output. And the equivalent partitioning is just like the input data and output data often fall into different classes, will be the member of the classes related. Each of the classes is an equivalent partition where the program behaves in an equivalent way. For the test, the classes should be chosen from each partition. Just like what if there are invalid input and valid input, the 2 things, and these are just the basic partition for that. And additionally, we are going to see the maybe, for example, we're going to partition system inputs and outputs into an equivalent sets. If we input is 5-digit integer from 10,000 to maybe 99,999, the equivalent partition should be less than 10,000, greater or equal to 10,000, and less than 90,000 and 99,999, or greater than 10,000. I think it's 100,000. And to choose the test case of the boundary, just like 0, 999, 10,000, 99,000, and 999, 10,001. Okay, and maybe it's like 100,001. They're more likely to display the numerous. They are more likely to display the erroneous behavior than choosing from random values. Additionally, the equivalent partition, that what if it's less than 4, what if between 4 or between 4 and 7, we can choose 3, 4, 7, 10, 11, and what is less than 10,000, or 10,000, we can choose 9,999, or it's 10,000, and just this boundary where you can choose the middle value, and maybe you can choose the 99,999, and maybe 10. Additionally, we are going to search rule specifications where we produce the procedure search key element, whether we can. The precondition is that the array has at least one element, and the first is less or equal to the last. Then the post condition is the element found or is referred by T or is not in the key. The search routine is input confirm the precondition. The input the input where precondition does not hold. The input where the key element is a member of the array. The input of the array which is not in the array. The testing guidelines. The testing software with sequences which may have only single values use the sequence of different sizes of the different tests, derive the test so that the first, middle, the last element has test, and design the sequence of zero length, just like we can design array of single value, design array of more than one value, design array, and what if it's we can design maybe since the array must be non-empty, we are going to design single value single value not in element more than one value, first value in sequence more than one, last value in sequence, middle value in the sequence, or the not in the sequence, right? Therefore, there are two kind of arrays, which is single value or multi-value, and single value can in sequence or not in sequence. More than one value is first, last, middle, not. And it's just like we're doing the correspondingly, it's 77, 77. And the first, the last, the middle, the not in this one. The structured testing is just like we are whiteboard testing or glassboard testing, can derive test data according to the program structure. Knowledge of the program is used to identify the additional test cases. The objective is to exercise all the program statements. The whiteboard testing we have we are going to start at the component code and derive the test data, then to test whether it's max or not. For example, we have if we want to test the binary search, we need to know that it's going to do the partition. The precondition satisfied. The elements a key element in array case precondition satisfied key elements not in the array in precondition unsatisfied the key element in the array, the precondition unsatisfied the key element not in the array. Just like the permutation of the thing. An input array has single value, input array has even number of values, input array has odd time. These are the things that will make something different. Yeah. And the binary search or equivalent partition is just like what if the element is less than the mid, or it is greater than the mid, or it is right exactly the mid. And in this case, it's just like this is the original thing, and this is also the case. But what if it is even number? What if it is even number? What is this is last, this is the middle, and this is just before middle, and this is So what is this is what if we change why we change this one? Why is this one? And this is not found. Okay. So in this lecture, the testing puzzle system are commonly used rather than those which are really test parts of the system are commonly used rather than those are rarely used. Equivalent partitions are tests of the cases where the program should behave in an equivalent way. Blackboard testing is based on system specification, and structural testing identifies the test cases which cost all the paths. It's trying to the main difference between the structural testing and blackboard testing is that in the structural testing we are going to consider the even cases or there are even number of problems or there are odd number of problems. That is very different because that is different in the binary search problem. Okay, thank you very much. Welcome for coming.